Welcome to ehiddenbrain.com. Today we will see principle of inclusion-exclusion. Principle of inclusion-exclusion. Now, what is the principle of inclusion-exclusion? It is a counting technique, right? For calculating or finding, or you can say for calculating number of elements in union of two sets which are finite in nature, right? So it's a calculating technique. Now let's say there are two sets. For example, let's say there are two sets x and y. X is 1, 2, 3 and 4 and y is 4, 5, 6. So now if I make a union of these two sets, what you will get? You can say that if I do the union of these two sets, what I will get? I will get a set called 1, 2, 3, 4, 5 and 6. Means there are 6 elements. I can say mod x union y will be how much? 6. Now how to do it? Using a Venn diagram, or rather using a formula, and that formula is called as a principle of inclusion-exclusion. You can see this can be achieved in this way. What I will do is I will have x with me, I have a y with me, right? So this is x, this is y. Now 1, 2 and 3 sits exclusively for x and the 4 is common, and then I have 5 and 6. So you can see this 4, 5, 6 belongs to y, 1, 2, 3, 4 belongs to x. Now if I want to do a mod x and y, like if I do want to do mod x union y, what I want to do is I will say mod x. Now what is mod x? Mod x is 4, means there are 4 elements present, plus mod y. Now you can see that there are 3 elements present, so this will give you 7, but the answer is 6. It is not correct, right? So what is happened here? You can see this, while calculating this, 4 is counted once, right? And while calculating y, 4 is again counted, means 4 is counted twice, right? And that's why we have to exclude it. We have to include also, but what we have to exclude? We have to exclude the common part once, right? Means I can exclude x intersection y. So this is a formula, you can see this. So this part should be excluded once. And what you will get, you can see this is a formula, and this formula is called as a principle of inclusion and exclusion. It is very simple, right? Now you can see this, we can actually get answer for the above question. What it is? It is 4 plus 3, mod x is 4, mod y is 3, and then minus intersection element is only 1. So I will get a 6 as answer. So I hope you understood principle of inclusion and exclusion. Now the same formula will be used, or the same technique will be used for 3 sets. So principle of inclusion exclusion for the 3 sets will be, so let's say these are 3 sets, and I call these sets as, let's say, x, y and z. So I will call this x, y and z, and there are some elements present, let's say. So there are some element present. I can call it as 1, 2, 3. Then let's say 4 is present in all, and then there is 5, 6 here, and then this set consists of 4 and 7, let's say. So this set consists of 4 and 7. Now let's say we can increase this. If you really want, I can increase it by, let's say, -1, -5, and then I can increase this by -7, let's say, something like this I do. So you can see this x consists of 1, 2, 3, -1, -7 and 4, and y consists of -1, 5, 6, 4 and -5, and z consists of -7, 4, -5 and 7. So how to get this? How to get a formula now? You can see this, mod of x union y union z will be equals to, I can say, mod x plus mod y plus mod z. Now what is mod x? You can see that how many elements are there? 6 elements are present here. Means mod x consists of 6 elements, mod y consists of 5 elements, and mod z consists of 4 elements. But actually when you do the union, how many elements really we will get? 6 and this 4 means 10 elements should be there, but this is giving 6 plus 5 plus 4 means it is 15. What is the answer? Answer is 10 and we are getting 15, so we definitely has to subtract something. So what we will be subtracting? You can see that I will be subtracting what happened in I considered x, then I considered y, and then I considered z also. Means this portion is considered twice, this portion is also considered twice, and this portion is also considered twice. So I will try to subtract this. So what I will say, x intersection y is considered twice, so subtract once. Then x intersection z is also considered twice, so subtract once. And then y intersection z is also considered twice, and then subtract it. But what will happen if I subtract? How many elements mod x and x intersection y is having? You can see that 2 elements it will be having. So this is 2 elements. How many x intersection z is having? Again 2. And how many y intersection z is having? Again 2. So what will happen? You can see that 15 minus 6 will be actually 9 you will get, right? So yes, again you are getting a wrong answer. Means what happened? You can see this area, rather I can show this area is subtracted all the times, right? This area is subtracted all the times. You can see this. Though it is considered, then it is subtracted. Though it is considered, then it is subtracted. Though it is considered, then it is also subtracted. Means what happened? All the time I am subtracting that area, and that area is not considered in the final answer, and hence I will include that area x intersection y intersection z. And how many elements that x intersection y intersection z holds? 1 element. And you can see this. Finally, how many elements you get? 15 minus 6, you will get 9 plus 1, 10. Yes, so you get a final answer as 10. And this is a formula of principle of inclusion and exclusion for 3 sets. I hope you understood this. Now we will take the simple and smaller example. See the example, and the example is survey of 80 students says 30 like cricket and 60 like football. How many like both, right? So it's a very easy example of principle of inclusion exclusion. So things are given here. I will show you in terms of Venn diagram. It is always better to draw Venn diagram. It is 80 students, right? Out of that, the division is there. One is for cricket, one is for football. C denotes cricket, F denotes football. And now what is there? Actually, you can see this 1, 2 and 3 parts are there of Venn diagram. We know we want to calculate the third part. We know one part completely like this. We know C, but we want to exclusively calculate third part. So how to do it? Use a principle of inclusion exclusion. Mod C is given to you. Mod C is 30. Mod F is also given. Mod F is 60. Now which formula you gonna use? Use this formula. Mod C union F is equals to mod C plus mod F minus C intersection F, right? What is C union F? C union F is given to you, which is 80, you can say. So this is 80, which is equals to mod C is also given 30 plus mod F is also given 60. And now this is the required part, mod C intersection F. Now let's take this to this side, left hand side, and then you will get C intersection F is equals to 90 minus 80, which is equals to 10, I can say. And hence the required answer is 10. I hope this is very clear and simple problem, right? We'll see a little bit complex problem in the further videos. Stay tuned. Thank you.